The first pictures of India's Vikram lander on the surface of the moon have just come in. They were taken this morning. This picture of the Vikram lander at the Shiv Shakti point arrived courtesy ISRO earlier today and has enthralled millions of people all across India and all across the world. I can tell you, for the last 8 days since the lander arrived at the Shiv Shakti point, everyone's been waiting with bated breath for that first image of the Vikram lander at its landing spot. And there is that image, courtesy the little Pragyan rover, which has managed to turn around and take this gorgeous image of the Shiv Shakti point. On the other side of your screen is the Aditya L1, India's mission to the sun. We've conquered the moon's south pole. Now ISRO is headed to the sun. And these are the first pictures of the Aditya L1 space probe, the solar probe, ensconced inside its giant rocket, fully primed and ready for a Saturday noon launch that we'll be getting to you completely live.
Smile, please. And with that witty caption, ISRO dropped the one picture we have all been waiting for. This, ladies and gentlemen, is the beautiful Vikram lander that made all our moon dreams come true. Standing sturdy and tall at the Shiv Shakti point on the moon, Vikram has been captured for the first time by rover Pragyan's super effective navigation cameras. Termed very fittingly as the image of the mission by the ISRO team, you can see clearly that Vikram is hard at work. No rest, clearly, even after touching down and making a billion dreams come true. Vikram's 3 payloads are all functioning as seen in this image. The Chest and the ILSA are touching down on the moon's surface and conducting tests. The Chandra's surface thermophysical experiment measures the temperature profile of the lunar topsoil around the South Pole to understand its thermal behavior, while the ILSA, or the Instrument of Lunar Seismic Activity, measures the seismic activity at the Shiv Shakti point. It is not just Vikram that's loaded to the T. Rover Pragyan is also conducting several experiments and has now found the presence of sulfur also.
तो उसमें जो खासकर बात बाहर आई है कि सल्फर की जो स्पेक्ट्रल लाइन है वो क्लियर दिखती है, जो पहले अन्य जगह पे उतनी क्लैरिटी से नहीं दिखती थी। तो वो साउथ पोल पे जो भी ज़मीन उन्होंने एनालिसिस की, उसमें सल्फर का प्रेजेंस क्लियरली दिखता है। तो ये अपने एक अलग प्रकार की और एक अलग तरीके की खोज कही जाएगी, जिसमें सल्फर का स्पेक्ट्रल कंपोजिशन पता लगता है।
Pragyan has moved several meters away from the lander now, as evident from these pictures released by ISRO yesterday, which showed the rover retracing his steps after coming close to a massive crater on the lunar surface. The world is absolutely stunned by all the photos and videos released by ISRO, as the Chandrayaan mission is now at the halfway mark with 7 more glorious days of Pragyan's moon adventure left. Bureau Report, India Today.
And India Today's Sneha Murdani explains what the Aditya L1 mission is and why it is so significant. Watch this explainer.
Riding high on Chandrayaan 3's successful landing, ISRO is now gearing up for the next cosmic quest. Aditya L1 mission is what we are talking about. This is ISRO's first solar mission. We're talking about India's feet on the moon, eyes now on the sun. Let's talk about this particular mission, Aditya L1, which, like I said, is ISRO's India's first solar mission. The vehicle first. Aditya L1 is going to be hitching a ride on India's heavy-duty launch vehicle, which is the PSLV-XL. The PSLV-XL weighs 320 tons and the height is 44.4 meters. The PSLV-XL is a 4-stage vehicle with multiple satellite launch capabilities and multiple orbit capabilities. Just take a look at how this essentially is going to take off and place itself on the the sun's halo orbit.
And liftoff.
What then is the Lagrange point? Now named after Joseph Louis Lagrange, a French mathematician who first studied them in the 18th century, the Lagrange points are points in space where the gravitational forces of two large bodies such as the Sun and the Earth balance out, creating a region of equilibrium. Now these points in space can be used by spacecraft to reduce fuel consumption needed to remain in position. There are 5 of them: L1, L2, L3, L4 and L5. L1 is about 1.5 million kilometers from the Earth, or approximately 1% of the Earth-Sun distance. It is essentially the vantage point. Let's talk about the journey to L1. Well, after being placed in a low Earth orbit by ISRO's PSLV-XL rocket, the orbit is going to be made more elliptical, and spacecraft will be launched towards L1 point by using on-board propulsion. As the spacecraft travel towards L1, it will exit Earth's gravitational sphere of influence, or SOI. After the exit, cruise phase will start and craft will be injected into a large halo orbit around L1. It is going to take 4 months for the spacecraft to reach its destination. So why are we studying the Sun? The Sun, remember, is the nearest star and therefore can be studied in much more detail as compared to other stars, for example. Now, by studying the Sun, we can learn much more about stars in our Milky Way as well as about stars in various other galaxies. Sun's explosive solar phenomena, if directed towards the Earth, could cause various types of disturbances in the near-Earth space environment. To learn about and track Earth-directed storms and to predict their impact, continuous solar observations are required. Every storm that emerges from the Sun and heads towards Earth passes through L1. The various thermal and magnetic phenomena on the Sun are of extreme nature. Thus, the Sun also provides a good natural lab to understand those phenomena which can't be directly studied in any other lab. What then are the main objectives of this solar mission? The spacecraft carries 7 payloads designed to study the Sun's atmosphere and its interaction with the solar wind. The mission is aimed at studying the super high temperatures of solar corona, the dynamics of solar system and the solar temperature non-uniformity. It will also study and evaluate the main drivers of space weather. Let's now talk about Aditya L1 science payloads here. Now, of the 7 payloads, 4 will directly study the Sun and the remaining 3 will in situ carry out in situ studies of particles and fields at the Lagrange point, that's the L1. The science payloads of Aditya L1 are indigenously developed by different labs in the country. With 1 billion people praying for ISRO's success in unison, the countdown to Mission Sun has officially begun.
And I want to go across now and introduce you to Manish Purohit. He's a former ISRO scientist and very well-known space educator. Manish, welcome. Good to have you. Thanks for your time here on India Today. Very exciting time for all of us, and I can imagine what an exciting time it is for someone like you who's been associated with missions in the past. You are an expert on all things solar as well. What are you most looking forward to, Manish, about the Aditya L1 mission?
Thank you, Shiv, for the welcome. Actually, it's a big thing because India is taking big step forward in exploration. We have used Chandrayaan-3 for showing the intent that we are ready to explore the universe in a better way. We have been doing so. We have been to Mars. We have a Mars orbiter. We are planning again to go to Mars. But now we are going to Venus also. We are going towards Sun. So this tells us that we have that intent that, yes, we are coming to that particular part where space exploration is our next big aim. And that puts us in a very big picture if we compare with the global perspective. Now, talking about our Aditya L1. Aditya L1 is going to L1 point, that is the Lagrange 1 point. It is around 15 lakh kilometers from the Earth towards the Sun. Now, the best part about this point is there is nothing there. The spacecraft is going to go around in a halo orbit about there is nothing. Nothing is there. Only vacuum is there. So we are going to go around a vacuum point in a halo orbit, and these halo orbits are big. They can be like, farthest points can be like 6 lakh kilometers to 13 lakh kilometers apart. So these are the orbits, and they don't have a perfect shape. They are like Lissajous figures. They are distorted. So we have few neighbors also there. We have a company there also. There are few spacecrafts that are already stationed at L1. The best part for L1 is we get 24/7, 365 and 5.3. That is the time period for our Aditya. Complete duration, we will be looking at the sun in visible, ultraviolet and X-ray. These are the three possible ranges of spectrum where we want to observe sun as a star. Now, why we have to observe sun as a star? Now, let me put in a perspective. Take a 10 megaton hydrogen bomb and blast millions of them every second. And then keep doing this for billion years. Now, that's what is happening at the sun right at this moment.
Amazing.
So we have to understand why that happens. And these are called micro flares, and they have the power that is just billionth of a simple super flare or a sun flare. Now, sun flares are huge. Like, let's say if a sun flare I'm capturing, let's say I'm capturing sun and I'm getting a sun flare of this size. Let's say I got a picture of sun and I see a sun flare of this size, then put a dot anywhere, that will be Earth. So we have to understand that. 1859, we had a Carrington event. The name of the event is Carrington event.
Yes.
Sun was really angry, really angry. It threw up high energy magnetic fields, particles, plasma, what all you name, sun threw everything towards Earth. And if that happens now, world over, power grids will fail, networks will fail, and we'll go back to the Stone Age. So we have.
Absolutely. Yeah, finish your point.
So that's why we have to understand. Now, how we are going to do that with Aditya? Aditya is trying to understand that the core of the sun is at 27 million, surface of the sun is at 6,000, and the outer atmosphere is at 10 million. How? Why? What's happening there?
We feel the heat of the sun, we feel the power of the sun, and I feel the power of your passion about this mission. I can really feel it in your voice as well, and I share it with you. And Manish, I'd like to invite you to be part of our coverage on Saturday morning as well, when we welcome Aditya into low Earth orbit and then it blasts off towards the Lagrange point. It's going to be very exciting, and I really hope you'll make the time to be with us on our coverage. But for the moment, Manish, thank you so much for throwing some light, as it were, on the Aditya L1 mission. By this time on Saturday, ISRO's Aditya L1 solar probe will be in lower Earth orbit, preparing for its 4-month journey towards the sun, and we couldn't be more excited. I'm not going to get into the obvious of why humans need to study the sun, the star at the center of our solar system. That is the singular reason for the only life we currently know to exist in the known universe. And everyone knows why and how the sun has dominated cultures for millennia. What I did want to share with you, however, is a slightly morbid but utterly fascinating aspect of the sun. It is the sole reason why we thrive on this blue planet of ours. But as we obsess with our very terrestrial problems and the issues that divide us, as we ponder the infinite nature of life in the universe, I wanted to tell you or remind you that the sun will also be our end. Let's assume for a moment that humanity is able to save itself from obliteration and survive longer than this blink of an eye slice of time we have enjoyed thus far on the gigantic timeline since the origin of our beautiful Earth. If we miraculously survive and continue to flourish, then it will be the sun that brings humanity and all life on Earth to an end. It's one of universe's great ironies, but there's also comfort in how the life-giving sun is irreversibly programmed to finally bring our existence to an end. The reason? Well, the sun is a star, as you know, and stars have a finite life. Our sun, in 1 billion years from now, for instance, will be 10% more luminous. This alone will trigger a near total evaporation of the Earth's oceans and an end to what we call the carbon cycle, the very bedrock of life as we know it. In 4 billion years from now, the surface of the Earth will be heated by an expanding sun to temperatures that can melt solid ground. Of course, by this time, all life on Earth will be extinct. And finally, in a grand but slow finale, in about 7.5 billion years from now, the sun, having entered what is called its red giant phase, will have expanded enough to fully absorb the Earth. That's right, the Earth will become a part of the sun. There will be no life and no Earth left. all indications overwhelmingly suggest that humanity is unlikely to be around to see the looming end at the hands of our solar master. But that's the celestial beauty and cycle of life, the circle of existence, and hopefully a reminder that all things must come to an end, sometimes at the hands of that which we should be most thankful for. That's it on 5 Live. Thanks for watching. Coming up next, 6 p.m. Prime with Akshita. The Kaveri water war continues to escalate. It intensified to a feverish pitch. Karnataka's Deputy Chief Minister says that the government was going to appeal the top court to reduce the amount of water. It's become an even bigger fight than before. That big story next.